Imagine waking up one day to the news. Scientists have discovered a way to travel faster than light. Sounds like something straight out of science fiction, right? But what if I told you that some theories suggest it might actually be possible? What if we could reach another star in days instead of centuries? Could we bend space, create wormholes, or ride a warp bubble like in the movies? Or is light speed truly the ultimate limit? Today we're diving into the mind-blowing possibilities of faster-than-light travel, and trust me, you don't want to miss this. Ready? Let's go! The speed of light. Hey, have you ever wondered why we're stuck crawling through the universe at such slow speeds? I mean, think about it. Our fastest spacecraft takes thousands of years just to reach the nearest star. But then we hear about the speed of light, the ultimate speed limit of the universe. So why can't we just press the gas and zoom past it? Well, it turns out Einstein had something to say about that. His theory of special relativity tells us that as you get closer to the speed of light, 299,792,458 meters per second to be exact, things start getting weird. Your mass increases, time slows down, and eventually, it would take infinite energy to push you past the light speed barrier. Yep, infinite. That's more energy than all the stars in the galaxy combined. Now, you might be thinking, okay, but what if we just built an engine that's ridiculously powerful? That's the problem. No matter how much fuel or thrust you have, you can't outrun light. It's like a game with rules we can't break. And if we somehow did, weird things could happen, like time travel, causality-breaking paradoxes, or even physics itself collapsing. But hold on. Before we lose hope, some wild theories suggest that maybe, just maybe, there is a way to cheat the system. Enter warp drives and wormholes, two mind-blowing ideas that could rewrite everything we know about space travel. So, is faster-than-light travel possible? Let's talk about the crazy ideas that just might work. Theoretical possibilities. Alright, what if I told you there's a way to travel faster than light without actually breaking any laws of physics? Sounds crazy, right? But that's exactly what some theories suggest. Instead of moving through space, what if we could bend space itself? That's the idea behind the Alcubierre warp drive. Imagine a spaceship that contracts space in front of it and expands space behind it. The ship itself doesn't actually move, it just rides a wave of space-time, kind of like a surfer catching the perfect wave. The best part? Since you're not technically moving through space, you're not breaking the speed limit. But wait, you ask, why aren't we already building one? Well, there's a small problem. The warp drive needs exotic matter with negative energy, something we don't even know exists yet. Oh, and if we did find it, you'd need the energy of a small star to power the thing. No big deal, right? Then there's the wormhole idea. Instead of traveling across vast distances, why not create a shortcut? If space-time is like a folded sheet of paper, a wormhole would be like punching a hole straight through it. Instead of taking millions of years to reach another galaxy, you'd just step through and be there instantly. But surprise, surprise, wormholes also come with their own problems. They might collapse instantly, they might require impossible physics to stay open, and worst of all, they could be unstable portals of doom that rip apart anything that enters them. Fun, right? So, while these ideas sound straight out of sci-fi, scientists are actually exploring them seriously. And who knows, one breakthrough could change everything. But for now, we're stuck playing by the universe's rules. Or are we? Let's talk about the paradoxes of FTL travel, and why it might break reality itself. Challenges and paradoxes. Alright, let's say we somehow cheated physics and found a way to zoom past the speed of light. Cool, right? Well, not so fast. The moment you go faster than light, you break time itself. Yes, you heard that right. FTL travel messes up cause and effect, leading to paradoxes so wild they'd make your brain hurt. Imagine this. You hop into your FTL spaceship and fly to a distant planet faster than light. From your perspective, everything seems normal. But according to an observer back on Earth, you've just arrived at your destination before you even left. How's that possible? That's the causality problem, when effects happen before their causes. Now take it a step further. What if you send a message back to Earth using another FTL signal? Based on relativity, your message could arrive before you even sent it. Think about that. Someone on Earth could get your message and stop you from ever sending it in the first place. Congrats, you've just created a time paradox where reality contradicts itself. Welcome to the Twilight Zone, and it doesn't stop there. Physicists have proposed something called the grandfather paradox. What if FTL travel allowed you to go back in time and, let's say, prevent your grandfather from meeting your grandmother. You wouldn't exist, but then you wouldn't have been able to go back in time in the first place. These paradoxes aren't just annoying thought experiments, they tell us that something fundamental about FTL travel doesn't fit with our understanding of the universe. So, unless we find a way to rewrite the laws of physics, breaking the speed of light might just be the key to breaking reality itself. But wait, there's something even weirder at play. Let's talk quantum mechanics. A glitch in the speed limit. Okay, if faster-than-light travel is impossible, then someone needs to explain what's going on with quantum entanglement. Because in the quantum world, things seem to break the rules all the time. Here's how it works. Imagine you have two particles, one on Earth and one on the other side of the galaxy. If these particles are entangled, changing one will instantly affect the other, no matter how far apart they are. Sounds like instant communication, right? Well, not exactly. Even though this connection happens faster than light, it doesn't actually transmit information. You can't use it to send messages or travel through space, at least not in any way we currently understand. Einstein called this spooky action at a distance, and honestly, even physicists are still scratching their heads over it. But here's the interesting part. Some researchers believe quantum entanglement might be a clue that the speed of light isn't the absolute limit after all. What if our current understanding of space and time is just a piece of a much bigger puzzle? What if the universe has hidden shortcuts that we just haven't discovered yet? Some scientists have even suggested that quantum mechanics could be connected to wormholes, tiny microscopic ones that constantly open and close in space-time. If that's true, could we one day scale them up and turn them into real, usable wormholes for space travel? It's a long shot, but hey, so was flying once upon a time. One thing's for sure, the more we dig into quantum weirdness, the more we realize that reality is way more mysterious than we ever imagined. But what does all this mean for the future of faster-than-light travel? Is it just sci-fi, or could we actually crack the code one day? Let's talk about recent breakthroughs and what's next. Recent developments and research. Alright, so we've talked about how faster-than-light travel is currently impossible, how it could break reality, and how quantum mechanics might be hinting at something bigger. But what if I told you that scientists haven't given up yet? In fact, some mind-blowing research suggests that FTL travel might not be as far-fetched as we thought. Let's start with the Alcubierre warp drive. Remember that sci-fi idea where a spaceship doesn't move but instead bends space around it? Well, in 2021, a group of physicists found a way to tweak the original math, meaning that a warp drive might actually be possible without exotic matter. The catch? We'd still need insane amounts of energy, but hey, progress is progress. Then there's quantum tunneling, an effect where particles seemingly teleport through barriers instead of going around them. Some researchers believe this could hint at a way to manipulate space-time itself. If we ever learn how to scale this effect up to spaceships, we could be looking at a whole new method of breaking the speed barrier. And here's something wild. A 2019 study suggested that faster-than-light motion might actually be possible inside certain plasma waves. Scientists at NASA have even experimented with using plasma fields to manipulate light speed limits inside controlled environments. It's small scale for now, but what if it's a stepping stone to something bigger? Sure, none of this means we'll be zipping through the cosmos tomorrow, but science is all about small discoveries leading to big breakthroughs. If we can keep pushing the boundaries of physics, who knows? Maybe one day we'll look back and laugh at the idea that we ever thought FTL travel was impossible. So, with all this research happening, the real question is, what's next? Let's talk about the future of interstellar travel. The future of faster-than-light travel. So will we ever break the speed of light? Honestly, right now, it looks impossible. The laws of physics, time paradoxes, and energy requirements all stack against us. But here's the thing. History is full of impossibilities that humans eventually overcame. People once believed heavier-than-air flight was impossible. Then the Wright brothers came along. They thought space travel was just science fiction, until we landed on the moon. We believed breaking the sound barrier would destroy an aircraft, until Chuck Yeager proved everyone wrong. The point? Just because something seems impossible today, doesn't mean it always will be. The universe is full of mysteries we haven't unlocked yet, and every day, scientists are getting closer to understanding how space, time, and physics really work. Maybe one day we'll harness quantum mechanics, crack the secret of negative energy, or find a hidden law of physics that lets us leap across galaxies in seconds. Maybe we just haven't asked the right questions yet. But even if FTL travel never becomes a reality, our hunger to explore will never stop. The universe is vast, beautiful, and full of wonders waiting to be discovered. Whether it takes us a lifetime or a millennium, we're going to keep pushing forward, one breakthrough at a time. So what do you think? Will we ever travel faster than light? Or is the universe telling us to slow down and enjoy the ride? Let's talk in the comments. So, will we ever crack the code for faster than light travel? Right now, it's a mystery, but science is always evolving. Who knows? The next big breakthrough could be just around the corner. What do you think? Will humanity ever zip across galaxies at warp speed, or are we forever stuck crawling through space? Let's discuss in the comments. If you enjoyed this deep dive, subscribe to InnoVision Tech for more mind-blowing science and future tech content. See you in the next one. Imagine discovering a planet so massive, yet so close to its star, that it completely challenges everything we thought we knew about the universe. What if this planet could support life, but in ways we never expected? Sounds like science fiction, right? But it's real. Astronomers have found a super-Earth that defies logic, and it's closer than you think. What would it mean for the search for life beyond Earth? Could we be looking at a world with the potential for life? Stick around and let's dive into this mind-bending discovery that's got scientists rethinking everything. What is a super-Earth? Super-Earths are a fascinating class of exoplanets that have been at the forefront of astronomical studies in recent years. But what exactly makes them so unique? Let's break it down. Super-Earths are planets that are larger than Earth, but smaller than the gas giants like Uranus or Neptune. These planets are not necessarily made of the same materials as Earth, but they do share some similarities that make them intriguing. These planets are primarily rocky, much like our own Earth, and typically sit within the habitable zone of their stars, meaning that the temperature on these planets could be just right for liquid water to exist. And we all know water is one of the key ingredients for life. Imagine a world that's just a bit bigger than Earth, with the possibility of oceans, lakes, and maybe even life. Sounds like science fiction, right? But this is a very real phenomenon astronomers are uncovering in our galaxy. Super-Earths are typically located in the so-called Goldilocks zone, where conditions are neither too hot nor too cold. While this term might seem a little whimsical, it's based on the idea that these planets could potentially harbor life in a way that is very similar to Earth. They are a bit more massive than Earth, which can influence everything from gravity to the planet's atmosphere. The concept of a super-Earth challenges our assumptions about how planets form and what the possibilities for life in the universe really are. So next time someone mentions a super-Earth, just know that we're talking about planets with the potential to be life-bearing, and they're out there, waiting to be discovered. The discovery. Let's jump into the thrilling moment when astronomers made this incredible discovery, TOI-715b, a super-Earth that's capturing everyone's attention. It's not just the fact that it's a super-Earth, it's where and how it was found that's making waves in the scientific community. TOI-715b orbits a red dwarf star about 137 light-years away from Earth, a distance that seems far but is actually relatively close in cosmic terms. But here's the twist. This planet exists in the habitable zone of its star. What does that mean for us? It means that the conditions on TOI-715b could allow liquid water to exist on its surface. Yes, liquid water, one of the critical elements for life. The discovery of TOI-715b was made possible by NASA's Transiting Exoplanet Survey satellite, which is specifically designed to look for exoplanets that could potentially support life. Scientists are particularly excited about this discovery because TOI-715b is located at a sweet spot, not too close to its star to be scorched, but not too far to be frozen. This makes it a prime candidate for studying planetary atmospheres and understanding what it takes to support life beyond Earth. What's even more intriguing is that TOI-715b is about 1.5 times the size of Earth, putting it in that sweet middle ground that makes it an exciting prospect for further study. So, why does this matter? Well, TOI-715b represents a type of planet that could hold the key to understanding how planets with similar characteristics evolve and whether they could one day support life forms. Scientists are now looking forward to studying this planet in even greater detail. Could this super-Earth be one of the next steps in the search for life beyond our solar system? The discovery of TOI-715b has opened up a whole new chapter in the exploration of exoplanets and what lies beyond our own home planet. The anomaly. Now here's where things get really interesting. TOI-715b doesn't quite fit the mold of what scientists expected. You see, red dwarf stars are the most common type of star in our galaxy. They are much smaller and cooler than our sun, so any planets orbiting these stars should, in theory, be much smaller too. In fact, most of the planets discovered around red dwarfs are either rocky and small, or gas giants. But TOI-715b is something else entirely. It's a massive super-Earth about 1.5 times the size of our planet, orbiting a red dwarf star. And here's the kicker. According to current models of planetary formation, such massive planets should not exist around these types of stars. This discovery is throwing all of our previous assumptions into question. How did this giant planet form in a place where it shouldn't be able to exist? The answer isn't clear yet, but that's what makes this discovery so groundbreaking. It could completely change how we understand the formation of planets. Maybe it's not just the size of a star that determines the size of the planets that orbit it, but other unknown factors. Some astronomers suggest that the planet might have formed through a different mechanism, such as the accretion of a vast amount of material that wasn't initially accounted for. Others believe it could have been captured by the red dwarf star after originally forming around another, more massive star. Whatever the reason, TOI-715b's size and its location in the habitable zone has sparked a whirlwind of new theories about how planets, and potentially life, can exist in places we never imagined. In many ways, this discovery is a cosmic curveball, and scientists can't wait to learn more about how it fits into the puzzle of our universe. Implications for life. Now, you might be wondering, what does this all mean for life as we know it? Well, TOI-715b's potential to support life is one of the most exciting aspects of this discovery. The fact that this super-Earth exists in the habitable zone of its star, where temperatures are just right for liquid water to exist, is no small thing. Liquid water is essential for life as we understand it, and the idea that it could exist on another planet opens up the possibility that we are not alone in the universe. But there's more to it than just water. TOI-715b is a rocky planet, which means it has a solid surface that could potentially support life forms. In fact, it's the perfect candidate for future studies that aim to find out whether there could be signs of life beyond Earth. The size of the planet also plays a role in its habitability. Because it's larger than Earth, it might have a thicker atmosphere, which could help protect life from harmful radiation. This could also make the planet more resilient to changes in its environment. Could there be microbes living beneath the surface, or perhaps advanced civilizations on the horizon? While we don't have direct evidence of life on TOI-715b yet, the fact that it sits in its star's habitable zone gives scientists hope. If life can thrive in the most unlikely places right here on Earth, who's to say it couldn't exist on a distant super-Earth? The implications of this discovery are profound. It opens up the possibility of finding life in places we've never considered before, and sparks a renewed interest in the search for extraterrestrial life. So, while TOI-715b might not have aliens waving hello just yet, it's certainly a place worth keeping an eye on as we continue our quest to answer the age-old question, are we alone in the universe? The road ahead. What's next for the search for exoplanets like TOI-715b? Well, this discovery is just the tip of the iceberg. As exciting as it is to find a planet that challenges everything we know, it's also the perfect jumping-off point for further exploration. There's so much more we need to learn, and this discovery opens up an entirely new field of study. First off, astronomers are already working on detailed follow-up observations. They'll be using instruments like the James Webb Space Telescope to peer deeper into TOI-715b's atmosphere, trying to detect the chemical fingerprints of life. This will help us understand the planet's atmospheric composition, whether it has an atmosphere thick enough to trap heat, and if it could sustain conditions similar to Earth. But the search doesn't stop there. Scientists are already hunting for other super-Earths in the habitable zone of nearby stars. In fact, TOI-715b is just one of many super-Earths discovered, and there's a growing list of planets that might be hiding life right under our noses. What's truly exciting is that every new discovery adds a piece to the puzzle of how life could arise on different worlds. So, while we haven't found definitive proof of life on TOI-715b yet, the door is wide open. Who knows? Our future missions could uncover something that changes everything. We could be looking at the birth of the next great space-age frontier, where we begin to answer the question, what lies beyond our Earth, and are we truly alone in this vast universe? The road ahead is filled with questions, curiosity, and the infinite potential to change the way we think about the cosmos. The discovery of TOI-715b is only the beginning of an extraordinary journey into the unknown. So what next? So, after all this, what can we take away from the discovery of TOI-715b? This super-Earth has rewritten the playbook on what we know about planets orbiting red dwarf stars. The fact that it's not just any ordinary planet but one that could potentially support life is a game-changer in our search for life beyond Earth. We've long thought that red dwarfs couldn't host such massive habitable planets, yet here we are with TOI-715b proving us wrong. But this discovery is more than just a scientific curiosity. It's a reminder that the universe is full of surprises, places and phenomena we can't even begin to imagine. If a planet like TOI-715b exists in a zone we thought was too inhospitable, who knows what else is out there waiting to be discovered? Our understanding of planetary formation and habitability is evolving, and this find is at the forefront of that change. It's pushing us to think bigger and dream bolder. And this is only the beginning. With new tools and technology, we will be able to study planets like TOI-715b in greater detail, and who knows what secrets they might reveal. Could this planet hold the key to unlocking the mystery of life in the universe? Perhaps it's not just a possibility, we may one day find ourselves gazing at TOI-715b through a telescope, wondering if life has already taken root. For now, the discovery of this super-Earth has shown us that the cosmos is far more mysterious and full of wonder than we ever imagined. So, the next time you look up at the stars, remember that the universe is just getting started in revealing its secrets, and we're only scratching the surface. Thanks for joining us on this incredible journey through the cosmos. If you found this discovery as mind-blowing as we did, don't forget to like, share, and subscribe to InnoVision Tech for more groundbreaking insights. What do you think? Could there be life on planets like TOI-715b? Drop your thoughts in the comments below, stay curious, and we'll see you in the next video. Until then, keep exploring the edges of science and technology. Have you ever wondered if we're truly alone in the universe? What if Earth wasn't the only planet with life? Imagine gazing at the stars and realizing that somewhere out there in the vastness of space another form of life is thriving. Could there be other civilizations waiting to be discovered? Or maybe life is hidden in ways we never expected, on distant moons or planets. In today's video, let's dive into the mind-blowing possibilities of what could happen if Earth wasn't the only home to life. What would it mean for us and for the future of humanity? The search for extraterrestrial life. Can you imagine what it would be like to discover that Earth isn't the only planet teeming with life? Just think about it for a second. Out of the billions of planets in the universe, there could be countless other worlds where life exists. It's mind-boggling, right? For years, scientists have been searching for signs of life beyond our own planet, and each discovery brings us one step closer to answering the age-old question, are we alone in the universe? It all starts with the search for exoplanets, planets orbiting stars outside of our solar system. Over the past 2 decades, astronomers have discovered thousands of these planets, many of which reside in the habitable zone of their stars, also known as the Goldilocks zone. This is the region where conditions are just right for liquid water to exist, which is crucial for life as we know it. These findings have sparked intense interest because, if water can exist, who knows what other ingredients for life could be found. Take, for example, the discovery of Proxima b, an exoplanet located just over 4 light-years away. It's in the habitable zone of Proxima Centauri, the closest star to our Sun. Could this planet host microbial life, or even more advanced forms of life? We don't have the answers yet, but the possibility is enough to keep scientists on the edge of their seats. As telescopes improve and technology advances, our ability to study these distant worlds grows. Space missions like NASA's James Webb Space Telescope are on the lookout for biosignatures, chemical markers that could point to the presence of life. The more we explore, the closer we get to potentially answering one of humanity's biggest questions. Are we truly alone? But here's where things get even more fascinating. What if we discover not just signs of microbial life, but actual intelligent beings? Imagine communicating with another civilization from a distant star system. It's a tantalizing possibility, and each new discovery makes that scenario seem more likely. The rare Earth hypothesis. Okay, so here's a bit of a twist. What if Earth is special? I'm talking about the idea that the conditions required for complex life may be so rare that we might be the exception rather than the rule. This is where the rare Earth hypothesis comes in, and trust me, it's a game changer. According to this hypothesis, Earth's ability to support complex life like humans, animals, and plants could be the result of a perfect storm of rare conditions. Think of it as a cosmic lottery, where everything just happened to fall into place in the most unlikely of ways. One key factor that makes Earth unique is our distance from the Sun. We're situated just the right distance for water to exist in liquid form, which is essential for life. Not too hot, not too cold, just perfect. But it doesn't stop there. Earth has a magnetic field that protects us from harmful solar radiation, a large moon that stabilizes our planet's rotation, and even a gas giant like Jupiter nearby to act as a cosmic shield, preventing rogue asteroids from crashing into Earth and wiping us out. When you add all these factors together, it seems like the perfect conditions for life to flourish. But here's the kicker. What if all of these conditions are incredibly rare? What if other planets don't have this perfect setup? That's the concern behind the rare Earth hypothesis. Scientists suggest that even if microbial life is widespread in the universe, floating around in the watery depths of distant moons or in the clouds of Venus, the evolution of complex life might be a once-in-a-lifetime event. The chances of finding another planet with all the right conditions for complex life could be astronomically small. Now, this doesn't mean we should give up the search for extraterrestrial life. Oh no, the hunt for microbial life continues, and in fact, it's more promising than ever. But when it comes to finding another Earth-like planet with intelligent life forms, the odds might be stacked against us. Yet, isn't that what makes the search so thrilling? The fact that we might be on the brink of discovering something truly extraordinary, something so rare that it could change our understanding of life itself. Wouldn't that be the ultimate jackpot? The possibility of microbial life. Okay, so let's take a step back for a moment and entertain a fascinating idea. Even if Earth isn't the only planet with complex life, what if microbial life is all over the universe? The truth is, when it comes to the search for extraterrestrial life, microbes might just be the most common form of life out there. In fact, we might already be surrounded by the ingredients for life, and we don't even know it. Scientists are increasingly confident that the building blocks of life, amino acids, nucleobases, and other essential molecules, are widespread throughout the cosmos. These organic compounds, which are the foundation of life, have been found in asteroids, comets, and even on distant planets. Just recently, NASA's OSIRIS-REx spacecraft brought back samples from asteroid Bennu, and scientists were stunned to find the presence of amino acids in these ancient rocks. This discovery suggests that the raw materials necessary for life may be scattered throughout the solar system, just waiting to come together, but that's not all. The conditions necessary for microbial life to thrive might not be as rare as we once thought. Scientists have discovered that microbes on Earth can survive in extreme environments, places we would think are inhospitable for life. From the icy depths of Antarctica to the boiling hot springs in Yellowstone, life has managed to survive in ways that were previously unimaginable. This adaptability has led to the hypothesis that microbes could survive in similarly extreme environments on other planets or moons. Imagine, for example, the subsurface oceans of Europa, one of Jupiter's moons. These alien waters could harbor microbial life beneath their icy crust, a discovery that could revolutionize our understanding of life in the universe. The search for microbial life is gaining momentum, and scientists are now more optimistic than ever about finding it. The recent discovery of phosphine gas in the atmosphere of Venus, an indicator that life could exist in its clouds, has sent shockwaves through the scientific community. Although it's still debated whether the gas is truly a sign of life, the mere possibility raises new questions about the types of environments where life could survive. In the coming years, missions to moons like Europa, Enceladus, and even Mars may bring us closer to answering the question, is there life beyond Earth? It may not be intelligent life, but even finding a single microorganism could change everything we thought we knew about the universe. The Great Filter Theory. Now here's a theory that will really get you thinking, the Great Filter. Ever wonder why we haven't heard from any advanced civilizations in the galaxy? Even though there are billions of potentially habitable planets out there, according to the Great Filter Theory, the reason might be that there's some enormous, rare obstacle that most civilizations never make it past. It's like a cosmic hurdle that prevents life from evolving to the point where it can communicate with other civilizations or even travel across the stars. So, maybe we just haven't found extraterrestrial life because they've all hit that filter and wiped themselves out. Or maybe we're still ahead of us and the filter is something humanity is yet to face. Let's break this down. The Great Filter suggests that while the conditions for simple life, like bacteria, may be common throughout the universe, the jump to more complex, intelligent life is an incredibly rare event, and that's the part that makes the search for extraterrestrial life so difficult. If civilizations are doomed to fail before they reach a point of interstellar communication, then the search for intelligent life might be in vain. It could be that we, as humans, are among the few civilizations in the galaxy that have made it this far. But here's the truly unsettling thought. What if the Great Filter is still ahead of us? Maybe the self-destructive tendencies of advanced civilizations, war, climate change, or overexploitation of resources, are part of the filter that wipes them out before they can reach a stage where they could communicate with us. If that's true, it might mean we're walking a tightrope and that the future of humanity depends on avoiding this fate. The Great Filter raises some pretty terrifying questions. Are we truly alone in the universe because most civilizations self-destruct? Or are we just a young civilization, and the worst is yet to come? It's a theory that forces us to think about the future of our species and our responsibility to protect the planet. One thing's for sure, the search for extraterrestrial life isn't just about finding new species. It's about understanding our own place in the cosmos and what might happen to us if we don't make it past that Great Filter. Implications for humanity. Now let's explore the incredible possibilities that would unfold if Earth isn't the only planet with life. The discovery of extraterrestrial life, whether microbial or intelligent, would completely shatter our understanding of the universe. It would force us to rethink everything we know about biology, evolution, and our place in the cosmos. Imagine what it would feel like to learn that life exists beyond Earth, perhaps even thriving on distant planets. It's a mind-bending concept, but it's also an incredibly exciting one. If we were to discover extraterrestrial life, it would be a monumental moment in human history. Not only would we have proof that we're not alone in the universe, but we'd also have the opportunity to study entirely new forms of life. We could learn how life evolved in different environments, how it adapts to unique conditions, and how it survives in places we once thought were uninhabitable. This could open doors to entirely new fields of science, revolutionizing everything from medicine to energy production. But it wouldn't stop there. The discovery of extraterrestrial life would spark a global conversation about the ethics of contacting and interacting with alien species. Should we try to communicate with them? Or should we exercise caution, knowing that advanced civilizations could be far more powerful than we are? Would this knowledge change how we see ourselves as a species? The debate would be as much philosophical and theological as it would be scientific. Would the discovery challenge our beliefs about creation, God, and the nature of existence? These are the kinds of questions that would arise, and the answers would shape our future for centuries to come. And let's not forget about the possibility of intelligent extraterrestrial life. If we were to make contact with an advanced civilization, it would be one of the most profound events in human history. Imagine what we could learn from them. New technologies, new philosophies, and perhaps even the key to solving some of humanity's greatest challenges, like climate change, poverty, or disease. The implications for the future of humanity would be endless. The future of exploration. As we look to the future, it's clear that the search for life beyond Earth is only just beginning. The possibility of finding life, whether microbial or intelligent, could fundamentally alter the trajectory of human exploration in space. NASA, ESA, and private companies like SpaceX are already working on missions that aim to explore distant moons and planets for signs of life. Missions like the Europa Clipper, which is set to launch in the coming years, will explore Jupiter's moon Europa. Europa is thought to have a subsurface ocean beneath its icy crust, and scientists are eager to investigate whether this water could support life. Then there's the search for signs of life on Mars, which has been a focal point for researchers for years. Mars has water, ancient riverbeds, and signs that it may have once had a much warmer and wetter climate. Future Mars missions could uncover evidence of past microbial life, or perhaps even reveal that life still exists there today, lurking beneath the surface. But it's not just about exploring our own solar system. Advancements in telescope technology, like the James Webb Space Telescope, are opening up new frontiers in the search for extraterrestrial life on exoplanets. Scientists are now able to study the atmospheres of distant planets, searching for gases that could indicate the presence of life. The discovery of oxygen, methane, or even unusual chemical compositions in the atmospheres of distant planets could point to the existence of life. The future of space exploration is incredibly exciting, and the possibility of discovering life beyond Earth is no longer a distant dream. It's a tangible goal that humanity is working toward. Every new mission, every new discovery brings us closer to understanding whether we are truly alone in the universe. The implications of such a discovery are vast, but one thing is certain: exploring life beyond Earth will be one of the most significant endeavors in the history of humankind. So what do you think? Are we truly alone, or could there be other life out there waiting to be discovered? The possibilities are endless, and the search is just beginning. If you enjoyed exploring these mind-bending ideas with us, make sure to hit that like button and subscribe to InnoVision Tech for more fascinating discussions on space, science, and technology. What are your thoughts? Let us know in the comments below. Stay curious, and we'll see you in the next video.